Now that we have calculated the omnidirectional experimental points, we can visually inspect the results and we can extrapolate the variogram shape to the y-axis and pick a reasonable starting value for our nugget. In this case, we picked 0.11 nugget. In order to visualize how that nugget looks like when we fit these omnidirectional points with a variogram model, we can use the function rmsb.variomodel.fitExperimental. The class variomodel will specify a variogram in RMSB, and it has this method which is called fitExperimental that is designed for semi-automatic fitting of experimental points. This function will take the experimental variogram as input and will take also several other parameters. I do recommend the user to read all the descriptions of the parameters that are available to this function in order to get familiar with it. Throughout this notebook, I'm going to be explaining more parameters as we use them. You will see that we can specify a single number for most of these parameters, or we can specify a range. If we specify a single number, then we are just manually setting that parameter to be that number. If we specify a range, then we allow the function to optimize what the value should be within the specified range. Because we only want to see how this nugget looks like in a fitted model, we are just gonna specify the nugget to be the nugget that we defined manually. And we are gonna also be using the exponential shape, which is a common variogram shape for the gold variable. Because this is a omnidirectional variogram, the anisotropy ratio between range 1 and range 2 should be 1. And the anisotropy ratio between range 1 and range 3 should also be 1. Because this is an omnidirectional variogram, all the ranges should be set to the same value. Additionally, you will see that we can constrain the angles, and because this is a omnidirectional variogram, we want to restrict also the ranges to be all the same. So in this case, I'm going to select 0. We can go ahead and run this cell. So the result of the fitting is captured on this variomod output. And then we can use this variomod output to produce a plot. We start with the experimental variogram.plot that we already saw. And on top of the experimental points, we are adding the variogram model plot draw, and we just need to specify the same axis. So this is going to generate a figure with the experimental points and the variogram model. And we also take a look at the parameters that were used for this variogram. In order to look at the parameter table, we can do variomod.toTable, and that produces a table of all the parameters that were used for this variogram. We can now check the figure and evaluate if the extrapolation that we selected is adequate. If it is adequate, then we can stay with that nugget effect and move to directional variography. Of course, all these decisions are going to be validated. We can always go back to the nugget effect decision, change the nugget effect, and see how that has an impact on our validations.